So in order to, because we are going to use integration in our next few slides, I have placed the table, integral table on the left hand side and the derivative tables on the right hand side, because we will be using this derivative table also in the formula. So we can always come back and you can see how the results, standard results, are used. So for example, if you see over here, integral x to the power 9 dx, this is a single function. Another example of single function could be this. Integral 6 over x dx is a single function, because when you see it, you can bring the x from denominator to the numerator and it will become 6x to the power minus 1 dx. So this is a single function. So in this example and this example, you are integrating a single function. Another example of single function could be this. Integral cos 5t dt. So here, this trigonometric function cos 5t needs to be integrated with respect to dt. Let's take another example. And here you can see this is again a single function where it is 3 is a constant and sine 2x is a single function. So all these four are example of single function. Now another class that you could differentiate from this single function, integral of single function, is that you can have a situation where you have integral that you have to integrate and the integral consists of two functions. So it is not just x to the power 9, it could be x to the power 9 multiplied by cos x dx. So x to the power 9 is one function and cos x is another function. So this is an example of two functions. So let's come over here. So right now on the screen, you can see that it is required that we integrate this value x cos x dx. So we need to integrate this x with respect to dx and we need to integrate this cos x with respect to dx. So there are two separate functions. X is one function, a linear function, and cos x is another function, a trigonometric function. So this is an example of product of two functions. Okay? Another example for a situation when you are required to integrate and the integral value consists of two functions. Here it is, one function is x square and another function is exponential e to the power 3x. So again, as you can see, and if you compare it from the top examples, you can see that in this case, and this case, there are two functions that needs to be integrated with respect to x. Any questions on this? Okay, so the last example is another one, and this time I have taken x, a linear function, and log x. So log x is another function. So I have given you three examples that how product of two function is different than single function. And today's topic, what we are going to do is to integrate the product of two functions. So what we will be doing is not integrating the single function, but integrating product of two functions. So in this case, and this case, you can see that the integral consists of two functions. So I hope this example of difference between single function and two function is clear. Okay. So now I will come to today's topic, which is integration by parts. Now this integration by part is a special rule and it is applied for integrating products of two functions. So now when you see an integral and you find out when that integral consists of two functions, then what is required from you is to use this integration by parts formula. What is integration by parts formula? The integration by parts formula is over here on the screen. You can see integral u dv is equals to u v minus integral v du. Now, what is u, what is v, what is dv, and what is du? I'm going to tell you in the later slide. But at the moment, I just wanted to introduce you to what actually integration by part formula is. And integration by part formula is this. U integral u dv is equals to u multiplied by v minus v multiplied by du. And as you can see from the formula, application of this formula require us to have u anything equated to u, any other value equated to v, and when we have got u and v, we need to have du and dv also. And then we can substitute those u, v, du, and dv value in this formula to solve out our integral, which is a product of two functions. So these are the examples that I have shown you previously. Now, if you look at these examples now with the help of this formula, so over here, if you look at this formula, then you can see that somehow you can relate this formula with these examples. For example, in this formula, first one, x squared, and x, that's the first function, okay? And then cos x, e to the power 3x, and log x, it's the second function. So what is required similarity between this standard formula and these three examples is that in order to solve this integral, we need to make this x a value either u or dv, or we need to make this cos x as u or dv. So in order to solve this integration by this formula, we need to make one of the function as u and one of the function as dv. And then we are going to evaluate the answer based on this side, which is the right hand side of the formula. I will be solving this out in the next few slides, but I just wanted to show you that how this integration consisted of two functions can be related with the standard formula. Now, next slide, we look at how we came up with this standard formula. So this is how we came up with the standard formula. I will start from the right from the top, which is you have got a function y, which is a product of two functions. Now this u is a function fx, 1, and this v is another function fx, again x, consisting of x, but it's another function, so it's f2x. And a function y. Now if this y is equals to uv, then you can differentiate this y with respect to x. So in the next step you can see, and I'm sure that by now you know what the differentiation process is. So differentiating this y with respect to x, it will become dy by dx. And of course, we need to differentiate this u, the product of uv with respect to x. So here I am sure that this statement is clear to you, that all I have done is that I have differentiated both sides of the equation, which is dy by dx is equals to d by dx of product uv. And if you remember, we this on the side you can see this differentiation of a product. This is coming from week 8. If you remember, we did this standard and we used this formula and solved out few examples also, in which I said that if you are differentiating a product of two functions, then this is how you can differentiate, that you will take u multiply by dv by dx plus v multiply by du by dx. So all I have done is that I have brought that differentiation of a product formula over here, because this is what it's representing. Once I have used this right hand side and I have come up with the differential form of this product uv, I can rearrange this equation. What I can do, I can leave this du dv by dx on this side and bring this v du by dx on the other side of the equation, on the left hand side. And when I bring this term on the left hand side, this is how my equation will appear, that it will become u dv by dx equals to the product of differential product of uv minus v of du by dx. Now, this is the statement that can be integrated on both the sides of the equation. So in the next step, you can see that this statement is integrated on both sides of the equation. So here you can see with respect to x, so u dv by dx is integrated with respect to dx is equals to this term, first term, integrated with respect to dx minus v du by dx over here integrated with respect to dx. Now coming back and looking at all the three terms, you can see that the first term on the right hand side, this term, it simplifies, because if you remember, this dx and dx cancels out, and what is left is this u is equals to uv. So this duv can be replaced by y. Okay? So when you replace this by y, this is actually dy is this. This whole term is representing dy. Okay? Next, this particular answer can be equated by, if you integrate dy, your answer is y. So integral dy is y, which is uv. So all I have done, I have placed the value uv minus integral v du by dx times dx. I hope that till this point everyone is clear. Any questions on this? Any questions on this? I'm just trying to show you how the integration by parts formula has been derived, so that you can understand that the answer that you see is something that you will be using in your example problems, but it will still require you to do these things that are explained in the above steps. Okay, so I have replaced this first term by uv because it is representing integral dy, and if you integrate dy, you will get y as the answer, and y is actually uv. So I have replaced this over here. This v du by dx times dx, so this dx will cancel with dx, and what left over here is v du, and that's what you can see over here. So this whole term will become integral u dv is equals to uv minus v du. So I hope this is clear. Any questions on this?
Shazia,
Yes?
would you mind, just for clarity, pointing back to the tables? Like, how do you relate some of what you've done here back to the tables?
Okay. Let's go to the first example, and from there you will come to know where you will be requiring the table. Okay. At the moment, because it is just u and v value, it is very difficult to relate it to the table. Okay, because in table, if you go back to the table, you won't be able to see u and v. Yeah, you will be seeing the actual values. What I'll do is that I'll go to an example, because at the moment this u and dv is not that clear from the derivation, but once we will solve example in which I'm going to say u equals to x or x square and dv equals to cos x, then that will become more clear and you can use the table with those values. Okay, just before I go to that first example, if the thing I want to make clear is that now you know that integration by part is applied to an integral that is based on the product of two functions. For example, I just gave you integral x cos x dx. Now the question comes that which function should be made u and which function should be made v, because the formula requires u, v, du and dv. So first we need to make a choice to select what should be made u. Okay? So the choice must be such that when you select and when you look at the two functions and you select the one of them as u, that u should become a constant, so that if you are having u equals to x and you differentiate that x will become 1, right? I will give you more explanation of this later on also, but what I want to emphasize on, that when you look at the product of the two functions, you basically want to select the function that needs to be equated to u, the one that will become constant, not the one that will keep on getting subsequent values after that. And obviously, this will become clear in the next slide when I'll show you with the help of example. But this is something that you need to have in mind. So here, let's see. This is integral x cos x dx. So here one function is x, other function is cos x. Now, if you look at it, I want to make one of the function equals to u. Now, which of the functions should be taken as u? Anyone would like to? Yes.
X.
Yes. Why?
Or is it just because it's the first one?
Yes. It's not because it's the first one, because it will become a constant after differentiating. So if I take this as u equals to x, then du by dx will be 1. Okay, I'll clear this again. So see, now the first thing that you would look at is to look at the function which is over here, integral x cos x dx. The next thing is which of these two functions should we make u. And as I have stated, that you usually basically select the term, not because it is the first term, so it is u, and the second is the dv. No, it's not like that. You need to select out of those both these functions, the function that when differentiated will become a constant. So in this case, if I select this x equals to u, then this term cos x dx will become dv. Going back to the standard formula to remind you, look at the formula. U dv is equals to uv minus v du. So first I need to look at making one term as u and the other term as dv. So now coming back to this, which of this? So this is u and this cos x dx is dv. Okay, and the reason I'm taking this x as u is when I differentiate this u with respect to x, that is du by dx, x will become 1. If I had taken the cos x equals to u, then my du by dx will become sin x. It will again become a function or a term that needs to be integrated again. Okay, so the difference is I can't take u equals to cos x, because when I will integrate cos x, I will get an answer sin x, which can again be solved, requiring me to use a differential table. Or in case I use dv is equals to cos x dx, as you will see that when I will integrate this dv, I will get v equals to sin x. So by putting a trigonometric term as dv, it is likely to be solved easily as compared to making this cos x as equals to u. Now, this was just a sort of a general explanation for you to look at the terms and to select. Now, just for reminder that these were the three examples, and if you see, they were all the three terms had two functions, first function and then the second function. Okay, how to select this? Now, how to select which term needs to be u? Now, mostly there is this rule called ILATE rule. This ILATE rule is actually, ILATE is abbreviation of, I is abbreviation of inverse trigonometric functions. L is the abbreviation for logarithmic function. A is the algebraic function, which is polynomial, linear, quadratic. T is the trigonometric function, and E is standing for exponential function. Now this ILATE rule help us to choose u, which term to make u in integration by parts. So integration by parts formula, you have seen what integration by parts formula is, and when you look at an integral with product of two functions, just remember this ILATE rule. So inverse trigonometric function, so if the integral consists of inverse trigonometric function, some of the examples are 1 over sine x, 1 over cos x, 1 over tan x. So these are basically inverse function. Or it could be a product of logarithmic function, in which case it is natural log or log base 10, log x. Or it could be algebraic term with x square, x to the power 4, 2x, 3x, 1 over x. So all these are functions will be in algebraic functions. Then the trigonometric functions, which are basically simple sine x, cos x, tan x. And then the exponential function, which could take form of e to the power x, e to the power 3x, or e to the power minus x. Okay, so all these are some of the example of the functions. Now, how to choose u among all these functions? So the simple statement is that when you have to choose u, the technique of selecting u is that the closer this function is to the left, more likely it should be used as u. For example, if you have got a term x square, let's take the first one, the last one that we did. The last one was integral uh, uh, x cos x. Okay, so x is lying over here and cos x is lying over here. So because algebraic function is lying before trigonometric function, our x would be our u would be x and dv would be trigonometric function. Let me go back to the example and then I'll come back. So this was the first example, okay? So this is the algebraic function and this is the trigonometric function. This is the algebraic function and this is the exponential function, okay? Now looking at this chart, the first one was integral x cos x dx. So here, as you can see, algebraic function is lying left to the trigonometric function. Hence, x is u and dv is the trigonometric function. Then I gave you an example of x square e to the power x. So here, exponential function is lying to the most right and algebraic is lying towards the left. So hence u is taken to be the algebraic function and dv is taken to be the exponential function. Saying this is easy, but when we'll do the example, I'll remind you this eyelet rule and then you can see how the terms are selected. If there is any question on this eyelet rule, please you can have it now. Otherwise, when we'll do example, I'll try to explain this again. I hope this is clear. So just to remind you that the important thing or the key thing in integration by part is to choose u and dv correctly. Now, once you have identified that the integral consists of product of two functions, you are sure that, okay, now I need to use integration by parts formula. This is the step 2. The next step, which one to take u and which one to take dv. And for that, you need to use eyelet rule. Okay, so coming back to this example now, here x cos x dx, remember algebraic expression is lying before trigonometric. So here u is x and dv is cos x dx. The next example, again algebraic expression is lying towards left of exponential, hence u is x square and e to the power 3x dx is dv. Next is x log x dx. Now here the situation is different. Here log is lying left to algebraic expression. Clear? Or do you want me to go back to that slide? Okay, let's go back to that slide. So you see the logarithmic function is lying before algebraic function. So here u needs to be logarithmic function and algebraic needs to be dv. Okay? Clear? Okay, so let's do some examples. Now, I will start off with a simple, easy one. And in this case, you need to evaluate or determine the integral value of this x, product of x, e to the power x. So you need to determine the integral value of this product of two functions. One is x and other is e to the power x. Now tell me which one you would like to make u and which one you would like to make dv. Anyone?
Make x u.
Good. And e to the power x dx is dv. Okay, so step 1, again, if you have seen, I just want to remind this again because today's topic I have again put up as step 1, step 2, step 3, not only to help you understand, but also show to you that when you are attempting the problem, each of these steps have got marks. So if you skip some step, you may not be able to get full marks. So step 1, you have to make one of the function as u and other as dv. Okay, so here, as one of your colleague just explained, that x needs to be u. So if x needs to be u, e to the power x dx needs to be dv by dx. And here, if I take this dx over here, it will be dv equals to e to the power x dx. Okay, so it's just the way I've written it. Okay, otherwise dv is e to the power x dx. This whole thing is dv. Step 2. Now, once you have identified using eyelet rule which term is to be make u and which term needs to be make v, now look at the standard formula of integration by parts. So you have made integral x e to the power dx. Now what you need to do is to find out the right hand side of the formula. So you need to have u, which is over here. You need to have v, but you don't have v. Okay? Integral v, again you need to have v and du, but you don't have du either. So in order to determine this v and du, you need to do some processes on these two terms. So for this term, u equals to x, you need to differentiate this u with respect to x so that this becomes du, and you need to integrate this term with respect, integrate this term dv so that it becomes v. So if I differentiate this u equals to x, I will get du by dx equals to 1, because when you differentiate x, your answer is 1. So your du will become dx because you need du. Remember, in the standard formula, you need du. So this is how you got your du. Second term, you take this dv by dx e to the power x and you integrate this. So you see, integrate dv equals to integral ex dx. So I have taken this dx on this side. So my equation becomes dv equals to e to the power x dx, and I'm integrating both sides over here. Now if I integrate this dv, I will get answer v, which is required in the formula. Okay? And integral e to the power x dx, when integrated, this is the answer. That when you integrate e to the power x, your answer is e to the power x plus c. Remember, it is indefinite integral. There are no limits on integral. Last week we did definite integral. So the integral had the two limits, upper limit and lower limit. Right now we don't have any limits. So it's an indefinite integral, and when you integrate an indefinite integral, you always put a plus c sign. Okay? So the integral e to the power x dx, answer is e to the power x. I hope this step is clear. Any questions on this step?
So for that integration, you haven't used the tables, you've used that formula.
Yeah, so see, I have used the table over here. Okay? Let me go back quickly. So I need to integrate e to the power x. Okay? So e to the power x, when integrated, will give you result e to the power x. So the function ex, when integrated with respect to dx, the answer is ex. Is it clear?
Yes.
Okay. So just for sake of not to go back again and again on the table, I have just placed the direct answer over here, that when you integrate e to the power x with respect to dx, you will get answer e to the power x plus c. So now what you can do is, because you have find out you have find out v, you have find out v and du, you can use the standard formula and substitute all the values in this formula. So the first part, integral u dv, so u is x, dv is e to the power x dx. This is what you assigned. Initially, when you looked at it, you assigned these values, so here it is, okay? Is equals to, formula says u, so u is x, and what is v? V is this value. So I have tried to color code so that you can match where that value is coming from. So this is u, this is v, minus, according to the formula, minus integral. What is v? V is e to the power x, so here it is. And what is du? Du is dx. Is it clear? All I have done is that I have find out the differential of u and integral of dv, and I have substituted those values in the standard formula. According to the formula, now my u dv, u is x and dv is e to the power x dx. Okay, that is over here. Is equal to u. So the u value, what is u equals to? U equals to x. So here it is x. And what is v? V is, our answer over here is e to the power x. So I am placing v over here. Minus integral v. So v value is coming from here. And du value is coming from here. So all I have done is that I have placed my function values in the standard formula, and now I can simplify. This x multiplied by e to the power x will become x e to the power x minus, and what is the answer of this integral e to the power x? The answer to integral e to the power x is again e to the power x plus c. So if I integrate e to the power x dx with respect to x, my answer is e to the power x plus c. So as you can see, this x multiplied by e to the power x over here, minus sign as it is over here, and the answer of this integral from the table is e to the power x plus c. This is why it is very important to correctly choose u and dv. If you correctly choose u and dv, your dv will be very simplified in the end, and all it will require you is to look at the integral table and to find the answer. Just like in this case, integral e to the power x dx was e to the power x plus c. So the answer of this integral is x e to the power x minus e to the power x plus c. Another step that I can do now is to take this e to the power x common, so that within the bracket, answer, if I take e to the power x common from here, x will be left within the bracket, minus sign, and over here 1 would be left because I have taken e to the power x common outside. And this plus c will be there because I am integrating indefinite integral. And remember, when I did indefinite integral, I said that all you need to do is to place the constant in your final answer. Because, for example, in this case, we integrated before also, but we put the answer in C constant in the last answer, which is showing that it is indefinite integral that is being integrated. So you don't have to write C1 plus C2 for every step. You don't have to write a constant value as long as you write the constant in your end answer. I hope this example is clear. Yeah?
So for any time we're integrating by parts,
Mm-hmm.
whatever we make u is always differentiated. Is that correct?
Yes.
Okay.
Yeah? And it should always lie on the left-hand side on the eyelet rule. Yep. So when you are selecting u, prefer the u should be the value that is lying towards the left side. So if it is algebraic and trigonometric, then algebraic is lying left to trigonometric function. If you have got log value and algebraic value, then log is lying left to algebraic function. So log needs to be made u. Let's do another example. So we'll continue to do these examples so you will become clear how to use this integration by parts. Now in this example, you have got, and this is, I have given you example also. So by now you should be able to know that in this case, x is the algebraic function and cos x is the trigonometric function. Hence, because algebraic function is lying left to trigonometric function, and x is u and cos x dx is dv. So I will directly write over here that x is u, yep, and dv by dx is cos x. In the next step, according to the formula, I need to differentiate u and integrate dv. If I differentiate du, I will get du, and if I integrate dv, I will get v. Both these are required in the formula. So if I differentiate u with respect to x, my answer is 1. So my du by dx is du is equals to dx. And if I use this dv by dx equals to cos x and I integrate this dv, my answer will be v, and this cos x dx, integral cos x dx, the answer is sin x. And again, I have taken out the extract from the standard table, and here you can see that when you integrate a cos x function, your answer is sin x plus c. I'm not going to write plus c now because I'm going to write plus c in the end answer. Okay, so it is just to simplify, not writing constant all the time, but I will write the constant in the final answer. So now that I have find out u, pv, du and v, all I need to do is to put the value in the standard formula. So now my integral x cos x is u is x, v is sin x minus integral v is sin x, du is dx. Here it is. So here u is x, v is sin x. I got my answer over here, sin x, okay? Minus integral v is sin x, and what is du? Du is dx, because I've taken this dx on this side. So du is equals to 1 times dx, which is over here. I hope this is clear. Next, this integral, as you can see, can now be resolved easily because I have got a standard solution for this integral, which is when you have got integral sin x, you can get an answer minus cos x. So my answer for this integral is x sine x minus bracket minus cos x plus c. And this minus with this minus will become plus. And the answer to this sine x is cos x plus c because it is indefinite integral. Any questions on this? Okay, I'm assuming that you are all following. So this was the answer. Now, for the first four examples, I have taken very simple terms, taking the easy linear terms rather than going for the quadratic, especially in terms of algebraic. I haven't used any quadratic term. I will use those, and when I'll use those, then you can see how the solution slightly varies from the standard one. So in this case, here you have got two functions, x and log x. And remember, log is lying left to algebraic function. X is algebraic function, log x is logarithmic function. And logarithmic function on Euler rule is lying left to algebraic function. Hence, log x is taken as u. And when you take log x as u, then x dx becomes dv. Again, you will differentiate u with respect to x. It will become 1 over x. And when you differentiate this dv with respect to x, you will get v equals to x square by 2. Okay, so if I differentiate u with respect to x, I will get 1 over x. Again, you can find out, look at the differential table, and you will find out that when you differentiate log x, your answer is 1 over x. When you integrate dv, your answer is dv, v, and this x dx will become x square by 2. So all I have done in this step, I have taken this dx over here, here it is dividing the du, so on the other side it's going to multiply it. So here it is, I have taken dx on the other side, so it is this u after differentiating has become du equals to dx over x, and this term dv after integrating will become, this will become v, and this integral x dx will become x square by 2. And how I got this integral x dx? Now look at the standard formula. The standard formula says that x to the power m dx will be equal to x to the power m plus 1. So here m is 1. So m plus 1 will become 1 plus 1, 2. And divided by m plus 1. So again 1 plus 1 is 2. So I'm quite, you can relate it to your previous information as well as by looking at the table. So now you can see that I have found out all the terms in the standard formula, and I can place all these values in the formula because now I have got u, I have got v, I have got du, and I have got dv. So I've got all the four values. I can substitute in the standard formula. So here it is, that integral log x dx, so this is my u, this is my dv, equals to u is log x, multiplied by v, according to formula, it is v, so v is x square by 2. So here it is, minus integral 1 over x square into du. Du is dx over x, and you can see that I have tried to color code the terms so that you can relate how the values are coming into the formula. So in the formula it was integral v, so integral v multiplied by du, and du is dx over x. Now as you can appreciate that this is x square and this is x, so this x will cancel out, and what will left over here is x over 2 dx. So Be aware that while you are using the standard formula, there may be a situation where the the constant term or the x variable itself cancels out. Like in this case, x square is in the numerator and x is in the denominator, so this x will cancel out with one of the x. And hence, when this x cancels out, what you are left with is this term, which is log 1 over 2x square here, log x over here, minus, I have taken the constant out, this is 1 half, 1 by 2, out of the integral sign, and what is left over here after cancelling 1x is x. And again, as you can appreciate that by selecting the correct term or correct function as dv, our integral has become very simplified and we can integrate again this term with the help of same formula. So when we write the answer to this, our answer will be half x squared log x minus half x squared by 2 again. Okay, so if you can see over here that half x squared here log x over here minus half, this half is written over here, and the answer to this integral x dx using the same formula over here is x squared by 2 plus c, because we are solving the indefinite integral. And now this can be solved easily because it will become x squared by 4. So in the next step, you can see that half x squared into log x minus x squared by 4 plus c is the answer.